Hey, thanks for coming back for another video. So let me ask you a question. What is the worst thing, tedious thing to work on when it comes to an older bike like this, or even some of the newer ones? What would you think the answer to that would be?
No, this sucker's electrical.
See how that's sparking there?
So if you said electrical, you're right, because that is most definitely the thing. There are certain parts of these electrical systems that are kind of difficult and special. One of the things is probably the most important electrical part on a motorcycle. And what is that? All right, in my opinion, it's this right here, the instrument cluster, the instrument pack on your motorcycle. This is your visual and sometimes audible, depending on the setup, and certainly, with flashy lights and things like that, feedback system to tell you when something's wrong. Except on this one, which is particularly annoying, is that all your really critical information is on the center LCD display. And when that's not working, you don't have engine temperature, you don't have fuel level, you don't really know what's going on, and the engine temperature being the most important thing right there. Until something stops running, or until your oil light goes on because you got no oil pressure because you got an overheat situation. So that's important information on this display. I did have this display working. Not 100%. I did say 100%, but the clock wasn't working.
Everything now works on a display. The shift indicator works, fuel gauge works, everything works.
Couldn't see shit through it because it was all full of scum or whatever on the plastic, but it was working. And then it didn't work. I ended up taking this display, taking it to complete bits. My intention was just to clean the glass, if you will, if you want to call it that, the plastic. And when I saw the inside of it being so dirty, I said, you know what, we're going to go ahead and just take it to bits and clean everything. And when I put it back together, the LCD display would not work. So once it stopped working, I had to figure out why it wasn't working. And I took it apart again, and again, and again. I could not figure it out until I did. So the purpose of this video is to show you how I fixed this. So that's what we're going to do in this video. We're going to tear into this again because I want to try to fix that tachometer.
The tachometer most definitely is not reading accurately. I do not know what is causing that, but I know it's idling around 1,000 and it shows 500.
I have an idea how to do that. I was able to procure a second display. The only thing it didn't have was the front case and the back case. It didn't have the outside part of it. All I wanted was the guts. I got it from a really cool guy named Richard. Thanks a lot, Richard, if you see this. So that really helped me out a lot. But we're going to try to fix this once and for all and hopefully not screw it up again. Because if we do, there's going to be no saving it. We're going to have to try to source another unit like this or just go with an aftermarket one and try to convert the signal data that will be interpreted by that aftermarket. Anyway, let's move on with the video and I hope you get something out of it.
This thing works now, and it did work before, and then it didn't work. It's kind of hard to explain. I'm going to have to really tie all this together as we go on in the video and show you how this thing is built and where the faults are as far as where its weak points are, and come up with an idea as to why they did it the way they did. It really has to do with trying to cram so much information into a small footprint or a little bit of real estate here instead of having separate gauges and things like that. But how they did it is kind of stupid in my opinion, and I'm going to show you that. This is 100% functional. Well, we're going to tear it apart again because I want to address the tachometer issue here. And that lies right here, which is I'm going to replace the motor that drives the tachometer, which I should have done when I had it apart before. But we're going to tear it down to a point where you're going to be able to see the repairs that I made. I'm going to show you how to do that. So let's go ahead and do that. And we're going to take this one apart and get into it so we can at least fix this part, or at least try to fix it. And then we're going to put this one back together. I'll do that part off camera. And then I'm going to go over the fix on the parts inside here that I've identified as the weak points. This is something you can absolutely do in your home shop. No problem. You can do it on a kitchen table. So let's move on with that. So the first thing we're going to do is get this back cover off. That exposes the bolts that hold this metal bracket on. And that way we can take that part of it off. We don't need to tear this 100% down to bits to get at what I need to get at, which is essentially taking the tachometer out. We need to pull the front cover off completely. There's a couple other things I want to replace in here as well that I didn't have when I put this together. There's your back cover. Now this will be stuck on like a long lost relative after you won the lottery. So this is your back side here, speedometer over here and tachometer over here. So there is a ribbon cable that goes between all these terminals right here. And you're going to see that here momentarily as soon as I take these 10 mil, I think they're M8s, but it takes a 10 mil tool, I believe, to take these off. And that is where the fault lies. That's the Achilles heel on that. You can see a little bit of it right here. And like I said, I have another one of these. I have one of these that I cannibalize parts off of. And it's absolutely butchered. I scratched my head on this one for a number of days. I really did. I wasn't sure what the hell I was going to do. I got to the point where I was starting to price out aftermarket and complete displays, and then I'd figure out how to make the signal inputs work for whatever that display is looking for. So the tachometer would work and a fuel level would work and so forth. I mean, that would have been a nightmare because I'm no electrical engineer, but I could have figured it out eventually. We're just going to get this off. There's these little spacers inside here, so you got to watch them. And then washers on the bottom. I had to grind this one. It just didn't fit to this plastic here. And this is just one of these things, you know, when you work on these old plastic parts from motorcycles, I don't care what it is, they are almost always distorted. The plastic gets distorted. When you go to put something back together, it's like, why didn't this fit? It doesn't fit because over 40, 45 years or whatever, plastic just decided to expand or contract or warp or something. Nothing goes together and you got to massage it. So that's the little bit of massaging I had to do on this. All right, so now you can see here is that ribbon cable, and you see all this mess in here. It looks like a Christmas tree. It's all green and red. These are bodge wires. And I'm going to go and pull that other ribbon cable out now because I'm going to leave this alone as much as I can. I do not believe I need to disengage this. I only need to disengage this one, I think. We don't need to actually pull any of the center thing out to get this out. We need to take the front cover off. The 4 screws for that are here, 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 and here. Well, we don't need to do that. We can leave all the center section in and then just disconnect this ribbon cable from this module, which is a stupid way they did this as well. Anyway, let me get that other ribbon cable and show you because I don't want to mess with this any more than I have to, but this is the lengths I had to go through, but I'll show you it on the other cable. Okay, so here is the ribbon cable thing that I was just talking about, and this is actually the original assembly, which is really like a flexible circuit board if you really think about that. More on that in a little bit. That came out of this display, the original display on the Sabre. And as you can see that it is in pretty bad shape. On this side, it looks really bad. You know why? Because it is. And this is kind of where I was going with doing the repairs that you see here. But I refined my procedure, and we're going to go over this here in a little bit as far as how to do this and the best way to do it. I'm going to have to disengage some of these stupid bodge wires that I put on which didn't work at all and show you how I did it on here, which is the way I'd recommend you do this because this is the only way it's going to work out 100%. Inside here, this is all your different lights and so forth for illuminating the idiot lights on the front panel. This is actually like this inside there. What this screws down with these little brass pieces upwards for little sockets for the bulbs. So you can fold this down and then put that in. And then this one that swings down to the left goes actually the other way. This is those little touchpad key things for the clock set. So it would go that way. So that screws down to another part. I don't want to take this off because there's no need to, so you're just going to have to trust me on this. This goes down below there and lines up to where those buttons are. And I don't know what these kind of contacts are called, with the little rubber conductive pieces that just touch it. And so when this is hooked up like this, this is kind of flat at this angle inside there, so you can put these lights in. They line up again to those idiot lights. So ultimately, this gets turned up like this. You see how much of a fold it is right here. So that's number one problem. But the real problem is that this guy has to turn around and go in like that and go down inside just like you see it here. And there is your problem, because this thing gets stressed out, and the more you touch it, the more it just wants to fall apart. And that is the problem. Now I'm going to show you in detail here in just a little bit as to what the faults are on these. I'll give you a hint right there. You can see that the ribbon cable is broken. I actually tried to just bridge solder it right there, which was a stupid idea because it's 40 years old. But there is a lot more to this, because what you end up having is again like a flexible circuit board that goes to a actual, like, what is this made out of, fiberglass or whatever the material's made out of. This one here, not so much the one down here, but this one here, and then this little one that goes up to that module. Now the innards of that module are like this. This is what they look like without the display or anything. And I don't have that. I don't have all the pieces to that in front of me, so I'm not going to worry about it. But this is the drivers essentially for that LCD display. So there is the plug, and there's the female that this goes into. And again, it would flip around. It would end up going in like this, but it'd be cranked like this, just like this one is. And then all your pins here. Now I replaced this module. This is the original one that came out of this display. I replaced this module with the module that came out of the replacement display that I got. That solved the clock issue. So there was a problem in here that was causing the clock not to work. Over here is just another one of these modules that goes on the back of the tack. This does not go directly to the tack like through here or anything. This is just a little module. What it does exactly, I do not know, but it does go, it has something to do with the speedo, because these connections over here go over to the speedometer, and these two here, and this guy is the only one that goes to the tack. So this guy is the tack side, it goes over there. Now I changed, this is the original one that came out of this display as well. I changed that one out with the replacement display, and the tachometer issue with it reading low still remains. So it has to be something different, i.e. the driver motor for it, which is what we're going to replace here. So this is what you're dealing with when you take something like this apart. I'm going to get way into this more in a little bit. I just wanted to kind of give you an idea, because I'm not going to take this apart if I don't have to. The only one that's going to come apart is this one right here. I'll show you that. This is this section right here. You see these little flats that get pushed into a mating slit thing plug that is actually stupid in my opinion. So let's just get to the point where we can take this thing and get that motor replaced, and then we'll deal with this part, because I'm going to show you exactly how I fix this one, and we'll use this one as kind of the guinea pig. But anyway, let me get on with this, because that was the main reason why I wanted a replacement ribbon. When I first put the replacement ribbon in, I got this thing working 100%, this ribbon right here. And then I was moving wires around, doing wire management inside here. And when I pulled a wire apart, it came apart very hard, and it stretched and pulled this ribbon, kind of like it looks for this one all tore up, kind of being pulled from the side like that. And I tore a couple traces, and I went, you gotta be kidding me. But there's more to it, like I said. As usual, I lost a clip, so let me explain really quick that I do need to take most of this apart, unfortunately, including that white piece of protective plastic that's mostly transparent, because that plug plugs in through that. The one that I'm describing that I don't want to touch, the one I bodge wired, that needs to go. The back cover plate needs to go around the connectors, and all that needs to go so I can flip up the module on the left side and get that terminal off of it, that ribbon cable part that's plugged into it with that stupid connector. And then once I get all that out, then I can do what I need to do to remove the front cover. Nope, we got no choice. Either I abandon this completely, or I'm going to have to unplug this very carefully. And I don't think I have to take any of the other ribbon cable out. But I'm definitely going to have to free this up, because I got to get this plastic piece out, and I'll unplug this. I'll take this module out altogether, turn it over, because one thing I cannot do is break this ribbon cable here. That it's all over with if that's the case. So we are going to be very, very careful with this. But at least you get to see a little bit more inside here ultimately. I didn't think you would, but that's just a cover that holds this thing in place, and that doubles as the screws that hold this this plug assembly in place as well. Unplug it like that. Just like that. Now I can get this guy out and just leave this right where it's at, I guess. Let me give you a tighter shot of that so you can see what it looks like from different vantage point, because it's kind of hard to see that. So again, this is where it plugs into on the back side of that. Okay. The problem is the more this gets touched, the more possibility of something else breaking. And if something else, I've already bodged all the circuits. There's 15 circuits. I've already bodged all of those. So if something breaks over here, we're completely screwed. This is where the likeliest failure point's going to be, right there, because if you pull it to the side too far or something, or you yank it, then it's all over with. At that point, you're really totally screwed. Let's go ahead and get this light out. See, this is one of these sockets I was talking about before, one of these quarter turn ones. That's typical to what you see in a lot of motorcycles of this era. We just have to get this module out of the way. Okay, now, there's a yellow wire that goes, this is the wire that I was working with when I ripped the thing before, because I had to run it on the other side. I'm just going to leave that because we can just lay that over to the side. I don't want to take any chances on this, but what we can do is we can take this now and bring it up and over. And it's going to be kind of hard to show you, but I will show you anyway. And really, really gently work this thing out. You just got to be real careful with it, like that. And there's your yellow wire. We'll just leave it there. So this again is what this is on this one. It's the same thing, but you see how they fold it all. This stuff is all folded around on itself. It's an absolute dumb design in my opinion. But now we can get all 4 screws to take the front cover off. And there was some of this disintegrating foam that they plug in these bigger holes here, so I just stuck some back in. Now I stripped out the plastic on 2 of these screws that goes through to hold the cover on. And unfortunately, the more you do it, the more chances of this thing doing the same damn thing. But so far they're holding okay. So hopefully it'll last one more taking apart like we're doing here and putting it back together, I hope. We'll take this, kind of put it over here. Now I had to redo this reset button for the trip meter, and I'll show you how I did that. Yeah, I thought it came out pretty good actually. This is one of those rubber covers for a toggle switch. No, it's upside down, sorry, but it's the way it is. And I drilled the hole out, which is normally square. It has a square button. You can't, you know, it's disintegrated on even the one I got, the extra one. And then glued it in place. It works pretty good, but unfortunately it grabs that shaft like you wouldn't believe. And the reset mechanism on this speedometer was completely seized. I had to work on that for quite a while to get it unseized. That's because the rubber failed and all that water got in there. Oh, you know what? We do have to take these out. I forgot. Which is fine, we can just let it float. All the stuff inside of it should come with it. It's the stuff that it extends. Let me get you zoomed out a little more. All right, here we go. Just stuck. There we go. Perfect. The other thing I wanted to replace was, when I took this one apart, it was missing this little, there's like a foam gasket in here. It's very hard to see. And so there wasn't one in here, so I kind of made one out of some foam I had left over. It seems to work, but now I have 2 more of those that he sent me. And these surrounds for the around the speedometer and the tachometer that helps seal it off in that cover. You can kind of see one there. Just don't want to damage that. Those came off of the replacement unit because mine were all folded over on themselves. All right, so we can set this aside now and carefully kind of lay this back down here. This is the place that I'm really concerned about. Just super concerned about it. Because again, the more you mess with this thing, the more it's gonna potentially take a shit on you. But we don't have to take the module out, so that's nice. So now I can just unscrew these two guys, which is what we came here to do. And we'll pull the tachometer out. Set those over there. So when I had this all apart, naturally I cleaned everything really well, which is why you can actually see the damn thing. And then we got the cord, cable, whatever it's called, through it. And that's all there is to it. There's your tachometer. And all it is just a little worm gear with a motor that drives it. I suspect that this motor is probably bad, or at least part of it's bad, because again, as I said before, I changed this module out, which didn't make any impact on the tachometer whatsoever. And in changing the center module out, which is the remnants of it are here, as I said before, for the LCD display, that solved the clock issues. So what I'm going to do now is kind of carefully move this up out of the way here. And we'll get you down and we'll take this motor out of here. I don't know if there's any way to set this, you know, like to clock it or anything. I'm really not too sure how this works, to be honest with you. It does recoil back down to 0 on its own, but if we turn this by reaching in with a screwdriver, I think I did this last time. Yeah, see there, if I'm moving the worm gear now. Sorry this is upside down, but I can't get, see there's the little spot, I can't get in there otherwise. So when I turn the worm gear, you see this thing goes up. And then it'll come right back down. I'm thinking that this doesn't have a 0 point on this motor. In other words, there's no way for the system, the module, to know where this thing is at any given time. I think all it does is it puts, you know, it turns that motor a certain amount, relationship to whatever the module tells it to. And then when it stops, I think this thing just drops back. I mean, that's the only thing I can think of. But I'm not really 100% sure. So I'm just going to take this motor out and we're just going to swap it and see what happens and see if we need to do any tomfoolery in here to get this thing to work properly. I just don't know. I have not had this out before, but it seems to be coming apart okay. I was watching a video on YouTube, and he was replacing the drive motors, and he was talking about how those, you have to essentially set them like at a certain point, so they are at 0. So I'm just not sure about how I got another tachometer, so if I screw this one up, it's not quite as nice as this one, but yeah, it just kind of falls out. It angles away and then comes out. What does this do now? This does nothing. Huh. Well, that's interesting. You can see down inside there, it's got the similar little spring dealio that it has when it's regular actuated like a cable type, you know, with the magnet thingy that goes around and it comes back on its own. So maybe that's part of the problem. Let's look at the other one, because the motor's obviously out of it, and see what that looks like in the same condition. Well, I'd love to do that, but I can't, because as usual, I can't find it. I have spent the last 20 minutes tearing shit apart looking for it, and it is nowhere to be found. This is the one that we just took out. And I started turning it, and I went, you know what? That feels different than I marked this one with yellow. So these two feel definitely different. This one is kind of sloppy when it came out of it, and it has no feel to it whatsoever. So I think we're on the right track here. I think that this is the problem. I think this motor just took a dump. Who knows why, age, whatever. All right, so we're just gonna turn around and put it in. That's all we can do.
Well, good morning. We are back, and you will notice the sound's different because I got the lapel mic actually working now, which I did not realize yesterday. See, this is the deal. I got myself a new phone. This is an iPhone 17 for my regular, there he is, my buddy, my regular phone stuff. Finally had to do a restore. I just restored the whole phone just this morning because I could not get this thing to work on the lapel mic. Well, the new iOS has a setting in there that says for any type of a wired accessory, allow when unlocked or always allow. So I saw that and switched it over to always allow, and boom, it worked. So all that footage yesterday is all on the iPhone mic, which is why it sounds a little weird. But this is the motor I took out. I already replaced off camera yesterday. I replaced the motor on this with the one from the other display that I got. I don't really know what I'm doing here with this. I have no idea if this is the right way to do it or not, but I just rolled that thing around by doing a classic reach around inside here on the worm gear in there to, I got it to just rest back down on the needle down on the pin here. I don't know how this works. That's the problem. I wish I could figure this out, like test it somehow. If I could find the other one, I would put this one in and try that, you know, put like 5 volts to it. I have a variable output DC power supply. We could put 5 volts to different wires and see what it does and get an idea, because I'm not sure if this thing spins constantly at different RPMs, and then when the RPMs drop or the motor stops, you know, it does something like this and springs back. I don't know how this thing works. So hopefully it's going to work, but at least with the new motor, we probably have a better chance of it being accurately. I'm going to put this all back together off camera. You've already seen essentially these bodge wires down here. Then when we work on the other ribbon, the one over here out of shot, that's when you kind of see exactly what I did. And hopefully you'll be able to use this to make a similar repair if you have that same situation. All right, moment of truth. If it works, I'll turn the key, it'll go into a self-test on the gear shift selector, and then it'll come up with neutral. I'm not getting any power. I redid all this switch. What did I forget? And apparently I screwed something up. I don't know what Honda engineers were thinking when they designed this electrical system, but anyway, it took me 2 hours to figure out, and I'm tired already from this. Can I talk about anything else that doesn't have anything to do with what we're shooting a video on? Probably not, so let's move on. So anyway, let's try it out. Got power, we've got bugs hitting me in the head, but we've got a self-test and we've got a neutral indicator. The LCD display is working, the clock is working too. If you hit set and you hit like hour or something like that, you can set it. We've got idiot lights. Let's see, high beam light works. Yep. See what happens. Well, apparently we didn't fix that. So I don't know what that problem is. I can't really tell 100% sure which one of the igniters feeds that signal up to the tachometer. Drawing I have doesn't indicate which one of the igniters is the other. You know, which one is which rather. I did some wire tracing. Unfortunately, the wires are exactly the same color until they get into the main harness, and those wires are all wrapped up, so it's very difficult to tell. I think it's this one here, 1 and 3, that we replaced, but I'm not sure. So eventually I'm going to pop the seat, and I'm going to go ahead and do a reach around in there. I'm going to pop that other new igniter in, the replacement igniter for 2 and 4, and see if it makes an impact on the tack. If it does, then maybe that's why this 2 and 4 igniter, which is right here, believe it or not, I actually know where the damn thing is. This is most definitely the one for 2 and 4, and is most definitely an MB4. You can tell that because it says so. And if I put that in and it straightens it out, then maybe that's the reason why this igniter is larger than this one, because it's got additional circuitry to power, to send signals to Mars or something. I don't know. Maybe that's why. So I'm going to get to that eventually, but at least we ruled out the display. So maybe it is the igniter. So I can picture some Honda engineer, Hibachi Kama Sutra or something, and he's going, I'm working on this Sabre, but I got no place to put the electrical stuff. All the connections and the fuse holder and the fuse panel. Oh, here's a good idea. Let's just shove them all up in the front here where there's absolutely no room for all this crap. And then, it'll be fine. Tell you what. The power problem was twofold. I caused one of them. This is it right here. This is a plug I replaced off the ignition switch because the original was melted. The red wire was melted into the plug. I used these plugs and they were mismatched as far as the little locking tangs go. So it wasn't seating into the other plug correctly, but I still didn't have any power. So I looked at the wiring diagram and I see the black and the brown wire are the ones that I really need power into that fuse block, which goes in right here. And that was loose, so I fixed that, and now we got power good. All right, time has come. We're going to get into the nitty-gritty on repairing something like this. This ribbon cable piece of crap thing that some of these old, maybe many of these old displays come with, as far as the connectivity goes from the main wiring harness through plugs or connectors like this, through which essentially like a flexible circuit board, through traces, these copper traces that are embedded in like polyethylene or some sort of vinyl or something like that, and that gives it its flexibility, but it's also its Achilles heel. This is why over a period of time, and I'll show you exactly the location that these things break, and it's almost impossible to see unless you had really high magnification, or you had a situation like this where you could see obviously that some of them are separated, like that spot right there that I mentioned before. I'm going to get some gloves on because we're going to work on getting this white goo off of here. It's kind of like white smegma or something. It's a glue that they use to stabilize, I imagine, the connectors and also isolate them as far as insulating goes. We are going to use hot glue when we get this done to put it back together, just like I did in the other one. It's particularly important on this side of it because when we bodge wire, we're going to remove that crap that's on there right now. We're going to need to make sure those are stable. I'm going to show you how I do this as far as getting a really good mechanical connection in addition to a good soldered connection. So the tools you're going to need are not this. If you got an old Radio Shack soldering pencil like this, don't throw it in the trash because it does have some value, but you're not going to use it in this situation. You're going to need to go out and get yourself a good, or at least a decent soldering station like this. And you're going to need a desoldering gun of some sort. I like the kind like Wes Johnson uses on Watch Wes Work, where it heats up the tip just like this one does, but he pulls a switch on it like a gun. It looks like a heat gun, not a heat gun, a glue gun, and then it sucks the solder out. I got this from the Jungle store and it actually works very well for this. So I'm going to show you that too here. I'm going to heat everything up first, and then, well, once we get all this white stuff off, then we'll do that. And I'm going to off-camera desolder all these bodge wires, but leave it as it was. I'm not going to take it any further until we get into the actual good repair, but we got to clear this white crap first. We're going to use a combination of just physical force as far as scraping. This little thing I just use for this kind of stuff. It's a little paring knife or something that I bent up. We're also going to use some brake clean, so put some safety squints on. I got mine engaged. Absolutely, you want to do that. Make sure you're spraying this stuff around something that's not going to either ignite it or react to it. So in other words, don't put your work on a styrofoam pad or something because it'll react to that and melt it and maybe generate heat. This is just one of these old Radio Shack branded electronic work surface pads that I just happen to have laying around. It works pretty well. A couple rags just to soak up the liquid, because what we're going to do is just start soaking these things. And it's probably silicone, I'm assuming, that they used on this, but it is 40-year-old silicone. So, and this is not going to hurt the plastic down below it. At least it didn't on the other one that I did. And once it softens it up a little bit, we can actually get in here and start pulling at this stuff and it will come off, but it is tedious. It takes some time to do. So just keep reapplying some brake clean. And I also have an old toothbrush that I'm going to use to do the final stuff, but I'm going to get the big crap off with this. And it does work, it just takes some time. So you can get it off in chunks, but that brake clean helps immensely kind of separate it. So I'm going to go ahead and do that rest of this off camera and get every bit of this cleaned up on this board here. Don't really need to do it over here, but I'm going to anyway, just to clear it, get it out of the way. And of course, what's left on this board too, that's really important. All right, so here we are, we're all cleaned up. This stuff comes off like, I don't know, looks like popcorn or Famunda cheese or something, probably silicone. But you can get it off with some patience, some perseverance, and some brake clean. Now the brake clean is most likely going to delaminate some of this, as far as what this coating was, that it was attached most likely to the ring terminal side of the traces originally when they manufactured this, but it doesn't matter because our objective here is to go from one point here where the pins come out and go into that module over to where they begin actually on this one where the input side is from the main wiring harness. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 15 traces. And I hate the way they designed this one. Because these hard wires that go down for your clock set, they come in on one part of this little PCB and have a bridge trace that goes over to the cable, or the ribbon rather. And then the ribbon goes up to wherever it goes. In this case, this particular N1 goes up and comes around and goes to this side here. And we do have some breakage over here. I do not know if we're going to be able to fix that. We might try some. See this one right here that's broken that goes over there? I have an idea that we might be able to do something with that, but we might try one later on. Do not know. I tried a couple things on that secondary ribbon cable over to the left off camera. Unfortunately, it's outside the scope of time we have available in this video. Maybe we'll address it in a future video or talk about it at another time. The reason why these have to be so clean, of course, is because we got to desolder them and then we have to put our bodge wires in. We're going to focus mainly on these first, and I'm only going to show you one of these because they're a real pain in the ass. What you have to do is, because these stupid traces that they put on that go between these wires and these back side of the pins, basically, these three pins right here, that's the back side of them, or the front side of them, depending on how you look at it. So I'm going to do a couple of these and we'll do one of these. We're going to have to just make a little U connector, like a little U-shaped or a horseshoe-shaped bodge wire. This is a real pain in the ass to do, but the way I'm going to demonstrate this is the way I recommend, because again, you get a physical connection better than just touching it with solder and hooking it up and essentially piggybacking on the existing solder connection. So the first thing we need to do is desolder the ones we're going to start. We'll start over here and we'll do like a couple of these over here, and I'll show you what I mean. So when you look at these traces, you have to remember they don't necessarily go straight up somewhere. This one does. This one in the end goes up, comes around and goes over here. But there's one over here that goes way over here. So this one that's underneath the yellow wire is one of the pins on the main connector, and it comes up and around and down and goes all the way over to here and then bridges over to there. And there's another one as well. It's kind of weird like that, and it goes all the way over to here, comes in, goes down, traces down. So that would be the fourth one in from the left. You have to make sure that you're doing that properly, because if you cross it over to a different terminal, it's not going to work or bad things are going to happen. So I recommend you start from one end and work your way over. I'll show you the bodge wire I use. That's why I use, well, the wire I use only has two colors, green and red. That's why I alternated the colors. That way it's kind of easier to see that. So let's get these desoldered first. So I think my desoldering tool is heated up enough. It's the kind that has just a little plunger on it. You can tell it is the plunger type because the way it is. And all we're going to do is put this guy on here and get ready to hit the button. Well, I hit it I was premature. Damn it, I hate it when that happens. Put it on here. Let it go straight. Hit it. You got a nice desoldering location right there. And that's what you want to see. So that's the pin. That's the back side of that terminal coming through is what you see right there. And the same thing over here. We're going to come straight down on it. These are much smaller though. You don't need to hold it that long. So surface area, surface to mass. Whoops, let's try cocking the damn thing. I hate it when my cock doesn't work. Okay, one more on this one. There you go. And there's that one. Now if the trace comes up with it, that's just fine. We don't care about trace anymore, because the way they made these things is really stupid in my opinion. And this is where I segue into where the failure points are. Now you see you have a connector with a trace. You see I'm going to peel the rest of this trace up so you can kind of see it. There's your piece of the trace that's coming up with it. So you have that, which was originally connected probably through this laminate through to the actual trace itself. So this is like the ring terminal connector of it, the termination of it, right there. There it is. Now you can kind of see it separate, right there. So that guy is what connected to the trace. And then the pin comes through from the other side and then solders to that trace. But the trouble is, this is the point right here. You can see that little seam. This is the point right here where it's going to fail, because the way this thing has to bend, and the more it bends, and vibration over the years, and the fact that it's 40 years old and who knows what material, where they got this material from, this is where it's going to break at that edge. It's almost like it's a scribed line, like when you cut glass. I mean, this is like a perfect opportunity for this thing to crack right there. And you can't see that. And if you test the continuity with a meter, by putting a meter here and putting it as a joining circuit up here, when it's in this position right here, you're going to get continuity. And then when you flip it around and it's bent down, like it is when you plug it in and this thing's turned down this way, as I described earlier, that continuity breaks and you're scratching your head wondering, I don't understand why I'm getting continuity in all these, but the thing's not working. Well, that's because they're like impossible to see. There are cracks in these. So that's another reason we need to facilitate a bodge system to bridge all these. Not only because we can see that there's a break right here, but these are all cracked. So I can tell you right now that they're going to be no good. Even if this was in pristine condition, there's a chance that there's a few of these that are no good. So that's what we're going to do. This is not cooperating. So let me go ahead and show you now what the wire I used was and how to physically do this. Now I'm perfectly aware that you can desolder with a soldering wick. If you want to use one of those, that's fine, but I think the desoldering pump is better. So this is the wire I use. It's just regular phone jack plug wire. For all you young folks out there that don't know what this is, we used to have these things called phones that you actually plugged into the wall. And this is an RJ11 plug type with just 2 wires on it. And so it's pretty simple. And we're gonna cannibalize the wires off of this and use that. It is like 30 gauge, maybe even 32 gauge, I'm not sure, and it is stranded. I wanted stranded wire. I bought some bodge wire on the jungle site, was not happy with it whatsoever, so I ended up switching over to this. And it supposedly was supposed to be stranded wire, but I don't think it was. And so I'm like, well, there you go. I got the wrong cutters. We'll just get a couple of lengths off of here. I also got me a set of these guys, which are very fine strippers. You can set it to different sizes. And I found that if you go down to the pretty much the lowest size and be very careful, you can strip it. So what we're going to do is we're going to strip ourselves just a little bit off the tip. Make sure it's nice and squared off. And we're just going to get a little bit off the end. Just like that. We don't need much on this. We just need a little tit sticking out like this. Alright, so what I meant by a physical connection is we are going to essentially shove this into the hole that's adjacent to whatever pin we are putting this through. And if it doesn't work the first time, you need to desolder a little bit more. That gives you a physical connection, so you're actually parallel with the pin. So you're right next to it. It's like 2 poles sistered together. They're both stronger when they're together. And so this is what we're doing with this. It's not the easiest thing to do, but it is possible to do. This one's being really stubborn, but if you just kind of move the pin a little bit, usually can get a little bit of room in there. All right, it's pretty good there. I had to help it out with the screwdriver, but as you can see, it's pretty much right next to it. Now, as far as putting it on the left side of the pin or what, I would say try to get it on this way, because it makes it a little bit larger and there's potential for a solder bridge. You don't want to have any solder bridges between these two connections. It's probably not that important, because if you're careful, you're not going to get that anyway. But if you can kind of slide it over to where it's either on this side or that side instead of left and right, like I just did, probably in a better position for you. All right, we're going to solder it up now. It's probably best that you have this in a little vise or something. I had this set up differently, and I had my clamp-on bench vise, small one, like a jeweler's vise, and I put this in very carefully, and it was very secure. I can't do that over here where I'm working. I don't have another type of a vise, so what we're going to do is just use a pair of these vise grips with a couple of pieces of hose over the end of them. They're the long nose type. Loosely grab those pins, and this will weigh it down to the point where it's not going to move around a whole lot. It's better to have it stable. So the next thing we're going to do is put some of this no clean flux on here. This is junk from Amazon. It works, but the syringe sucks. Other than that, it's okay. And I got my soldering station soldering pencil here set at 662 degrees. That seems to be pretty good. I do need to wet the sponge that comes with it, though. The sponge goes up into right down to the bottom of the unit here. So there's the sponge right there. It just sits in that little spot. Okay, now we do our surgery. A little bit of solder, or solder, as the Canadians would call it, solder. These are the harder ones to do, which is why I'm doing them first. And that's about it. When you see that insulation start to deform, you're getting a good heat penetration into this. Now, we have a really good solder joint right here because it's down next to the pin. The pin is not deformed. You can tell that because it's not pushed in. Because you got to watch that. When you go to push these wires in, you can, again, push that pin out because there's apparently a wider spot that keeps it from going up in, and then the solder holds it in the other way. So now all we have to do is put this one in its destination, which is right over here. I should have made this a little bit longer, but this is for demonstration purposes anyway, because I found that when it goes to the left and you have a little extra, you can push to the side when you curl this around, and it gives a little bit more room to make that curl. And you saw that in the earlier part of the video, where it was kind of sticking out the left side when it was plugged in. We'll do the same thing. We'll get this thing just stripped down a little bit. You wiggle these things around, it works pretty good doing that. There we go. We just need a little tiny piece of it sticking up just like that. Now we just repeat the process. We're going to shove this down inside. These are so much easier because the pins are bigger and the holes are too. And then we'll solder it back up the same way. And you're going to have a good physical connection there. So now the trace is eliminated and you got a good bodge wire that's not going anywhere. Now if you wiggle this thing back and forth enough, you're going to damage the copper integrity at the end, especially if you nicked it a little bit with the strippers, which is, you need a microscope to see that. But it'll break eventually. It'll stress the copper out. It's been heated, so now the copper is kind of work hardened as far as that end goes, and so you just be careful with it. But all you have to do is 14 more, and then you're good. So I'm going to do one more on this main trace. We'll do one over here. Okay, so the one next to it, we might as well just do that. Goes from here, and if you want to, let me do this. If you want to, you can hit stuff and move it around because you're a clumsy oaf like I am. You can take like a red marker and then run it up that trace, the one that you're targeting, and then just bring it over and keep following that trace. And that's where it goes. And then when you're done with it, just wipe it off with a little alcohol prep or something and go to the next one. That way you don't confuse it. And that's what I did in the other one. It worked out really well. So we'll take our desoldering tool here and we'll get her ready to go. Try not to be premature about it. Good, that's one. Clean off that tip a little. And we'll do this one right next to it, the one we already did. And I'm holding a little bit longer again because that's just a heavier, it's more mass on that terminal. There we go. There's no power adjustment on the desoldering gun, but there is on the soldering gun. Rinse and repeat. We're going to use red this time because we're going green, red, green, red, green, red. Because I know this length is going to work pretty well, I'm just going to do both sides as far as stripping goes. This one fit in a lot easier because who knows what the quality control was when they made these holes to start with. Once you get a rhythm going, this doesn't take that long. A little bit of the flux. I highly recommend, again, one of these soldering stations. They are so nice for this kind of thing because you can get, it comes with multiple small little tips. Tips. There we go. I may add a little blobule over here on this one. This one is not quite as blobuled out as I'd like to see it. And the nice thing about it is since it's in a hole with the other one, if you were just piggyback soldering, as soon as you touched it again, it would pop out probably because of springage on the wire. But in this case, it's captured, so you can't. It won't do that, or it has less of a tendency to do that. And as we did before, we'll shove it into the hole next to the pin on the mating side of the PCB. All right, that's pretty good. Bada bing, bada boom. You can pull on that quite hard. They ain't gonna go nowhere. All right, let's work on one of these stupid ones. And they are stupid because I just think that this design is terrible. We'll do this end one, it's easier to get at. We're just gonna make a little U-joint. You would think that this is actually pretty easy, but it is not. Again, I'm gonna get rid of this trace here because we don't need it. You know, I understand there's a pin on one side and there's a wire on the same side, but couldn't they just bring these things around and just make the hole larger and put these wires next to the pins, kind of like I'm doing right now with the bodge wires? It seems like it would be a hell of a lot better solution than this, but yeah, what do I know? All right, now the best solution to this would be, because it's easier to work with a longer piece than it is a shorter piece, would be just to leave it long, and that way you can manipulate it better. But you know, guess what? When you flip, this thing gets flipped around almost, well, basically 180 degrees plus a little bit from this angle. This thing would jumble itself up and actually get in the way. The stuff that you go, I imagine you could just put it to the side like the other ones, but I prefer just to go with the shortest jumper wire, direct straight line or a little horseshoe shape as possible. I think that that fits best in this application. It is over to the side of the actual ribbon cable that gets rolled, so there is a little bit of room there, but not a whole lot. So we're going to end up making a very short bodge wire here that's just very difficult to work with, unfortunately. It's just the way it is. Especially when you're trying to do the same thing that you did before by shoving it into the other side. So I think what I ended up doing, what I found was the best course of action, was to leave it long and then shorten it and very carefully strip it, because you're getting a really good connection with these. So if you put little lateral forces on them, longitudinal rather, it's not going to hurt it. And this goes right next to that yellow wire without any drama whatsoever. Well, the Canadians say solder like solder, but at least I'm not sure if they pronounce aluminum wrong. You know, aluminium like the Europeans do and everybody else in the world. I don't know. I think they do. Okay, so there's the one side. Now what's going to happen is that wire right there, it doesn't have a trace that it's going through, which is attached to the circuit board, which affixes the wire. So you see how that moves now? But don't worry, because when we put hot glue on that, it's going to secure it just fine. So don't fret yourself over it. So we're just going to take and we're going to preform this and see if we can get in here and get this thing cut and stripped. I'm going to keep this as short as possible. Usually it's pretty easy for me to deal with short stuff. Oh! There we go. Need Dad's old pair of tiny needle dick pliers here. Beauty. Look at that. I mean, it's not bad flux except for the fact that the syringe part sucks. Like Major League. I think it's missing something on the back side of it that actually holds the end of the syringe in. Okay, and then you have your bridge connector for this yellow wire going to that terminal, which is you know, what's clamped on by the vice grips here. So anyway, that's all I'm going to show you on this. This is just your general purpose hot glue gun with general purpose hot glue sticks. Got this at Ace Hardware. Wasn't too expensive, and it works really well for this. And if you put this stuff on and one of your wires breaks, you can get this stuff off. Don't ask me how I know. Pretty easily, just like the white crap they put on here, in the same manner. So this is particularly the area that I would be concerned about, because remember, this thing's got to be folded around almost 180 degrees, especially these little jumpers right here. So we're going to take some hot glue and we're just going to douche it right in here. There's enough room when this curls around to facilitate this space, or I should say the space that the hot glue is occupying. And then all you do is just let it cure, which takes only a few seconds even, or maybe a minute. And the same thing up here. We're going to douche these guys and, you know, cover them up, give them some strain relief. Make sure you clean it really well, though, with alcohol or something before you do this. Otherwise, the shit won't stick too well. But once you do that, it sticks pretty well. And you get these little strings, but they kind of pop right off. Not a big deal. It's not conductive that I know of. And yeah, that would be pretty much the last operation before I went and put something like this back in service. But this hot glue works really well to stabilize these wires. This is a worst case, last resort procedure to get the thing working. If you had no other choice, the best option would be to replace it. But in lieu of that, since these are getting scarce, if available at all, this might be an option for you. And just done with crap laying around pretty much. I had to buy I bought the soldering station, probably mentioned that. It was like 110 bucks from Lowe's. It's a Weller, made in China, of course. And I think I mentioned before that this desoldering unit came from the Amazon, the Jungle store. But you can get the ones that, you know, the little trigger ones. I think those are better. But I just couldn't justify the cost because I didn't know this was going to work or not. But now that I know, I think I probably will invest in one of those for this kind of soldering. But yeah, so this, I'm telling you right now, if I did all these circuits on this main ribbon cable and put this in service in a display, this would work. Yeah, so that's about it. I'll throw in some clips now at the end of this video, what we did today. Yeah, it worked out really well, and I hope this helps everybody out. I mean, these things are unreplaceable, basically, unless you find some crap on eBay. I did look on eBay to find maybe another one to do exactly what I did, cannibalize from. And it was like 300 bucks, and they were absolute junk. I mean, they looked terrible. Big thanks to Richard up there in Northeast Florida. Sent him the money electronically with an extra, I think, 20 bucks for shipping. And then he sent me the display quick, and it came UPS. I had it like in 2 days. And then about a week later, I got the secondary package, just a regular padded envelope with some extra stuff in it. So again, Richard really helped me out a lot, man. Without that, I wouldn't have been able to do this. It would have been nicer if I wasn't stupid the first time and broke the damn ribbon cable. But hey, we found a good way to repair these. At least they worked out in this situation. And I think it'll last long term the way I showed you to do it. So hopefully it helps you out. Now, if you want to see more crap like this, you know what you need to do. Stand by for those clips from what we did today, what I did today. I think you'll enjoy it. God dang it, freaking fly is bugging me. All right, folks, I forgot one thing, one final thing. Never, I mean always, yeah, don't just repair, ouch, restore. We'll catch you on next video. I smell weed. We're up here at Burt Barracuda's St. Pete Harley Davidson dealership, 49th Street North, St. Pete. This is day 3 and the last day of St. Pete Bike Fest. And we're going to be doing the LED ride. That's LED, not L-E-A-D, but L-E-D. Led by Paul Sr. of Orange County Choppers, aka OCC. Which apparently there's one of these around here somewhere. I don't know. And so that's supposed to happen starting at 10:30. That's what I come up here for. And also to give the Sabre a shakedown cruise, because she needs one. Just to make sure everything's good. So far so good, no puddles, no breakdowns, runs really well, and fantastic on the interstate with those tapered roller steering head bearings and wheels balanced properly and so forth, so I'm real happy with it. So we'll try to get some video as we're going along, because I have a mount on the bike for this iPhone 17, which is supposed to have ultra or enhanced video stabilization. We'll see about that. So we'll see you when we see you. Catch you later. There he is. Walked over here at the right time.